All right, let's continue where we left off. In the first video, we froze the first row up here so that as we move around with our data, the labels stay up there. And then we added a new column so that we could convert each one of the times into decimal hours. So we have the decimal for the swim time, the bike time, the run time, and the overall finish time. And then also in the first video, we calculated the mean, standard deviation, and coefficient of variance for these four categories. And so from this data, you should be able to answer the questions related to the mean, standard deviation, and coefficient of variance. We need to now talk about how it is that we use the normal distribution and z-score. And the instructions right here hopefully make it pretty simple. Using the function x equals norm inverse, we can go into each one of these four categories and calculate the 25th percentile and the 75th percentile. The 50th percentile is the mean, so we're good to go there. All right, so we're going to calculate the 25th percentile and the 75th percentile. We'll do that in a minute. Equals norm inverse, and it tells you right here it's going to want a probability. So that's going to be 0.25 for the 25th percentile. Then it wants a mean, and you don't need to type this in. In Excel, if the value already exists, it's right up here, 1.137, just click on that, and it'll tell you it wants the value in G42. And then the standard deviation, that already exists as well. So we'll just click on G43. I say 7, it's 2. Anyway, so G42 and G43, those are the values we need, and that is it. And we can hit return on that, so 1.05. Now, you can check with your number, but approximately 25% of our swim times need to be below this time that was calculated for your data. So if you want, I mean, there's 40 up here, there's 40 times, and so 25% of that's about 10. You can go check just to see that this makes sense. Check with your time here, go up here and check that there are about 10 of these swim times that are less than an hour, 0.05, and that should be pretty close. Now, I didn't ask you to figure out the 50th percentile, and to calculate it is a little redundant, but if I could learn to type, it would be a whole lot easier. Let me just show you something. Norm inverse, and if it's the 50th percentile with a mean of 1.137, standard deviation of that, close that up, hit enter, and notice, let's take these down to 3 decimal places. Just as we expected, the 50th percentile and the mean are the same value. Okay, so that's why it's a little redundant to calculate the 50th percentile. So let's not do that. 75th percentile. Calculating that is going to be, again, I told you over here, reminded you, I guess, reminded you that the function is norm inverse. So we can put that right here, equals norm inverse, and it prompts you probability of 0.75, the mean of, again, 1.137, there it is. We'll use it. and the standard deviation of 0.25. Close those parentheses. Bam. You could also give a real quick check for this with the value that you have in your data for the 75th percentile. About a quarter of the data should be above 1.22, so you could go up here and just check through this list to make sure that it makes sense that in this set of data up here, there are about 10 times for the swim that are at 1.22, that are above, at or above 1.22. Okay, and you're going to want to do this. Copy that. You're going to want to do this for the bike time, the run time, and the overall finish time. You're going to want to calculate these values as well. Okay, and once you do that, then you'll be ready to go on to the frequency distribution table and the histogram. We'll talk about that in the next video. All right, so go ahead and in your group complete these percentile calculations, and you can start to think about the answers to the questions in the project here that are asking you about the percentiles. All right, see you in the next video when we're talking about the frequency distribution as well as the histogram.